All right, today we're going to pull back the curtain on a truly revolutionary piece of technology, the modern cloud-native data warehouse. We're talking about the kind of system that can handle 1 trillion rows of data and not even break a sweat. So, how on earth does it work? Let's dive in. So let's just start with that big central question, right? How in the world do you query 1 trillion rows of data and get an answer back in just a few seconds? I mean, it sounds kind of impossible, but it's not. And it's all thanks to a completely new way of thinking about data architecture. You know, the old way of building these things was, well, monolithic. Imagine building a house where the plumbing and the electrical wiring are all hopelessly tangled together. If you wanted to add a new bedroom, you'd pretty much have to tear the whole house down and start over. But the new way, the cloud-native way, it's like building with Legos. You can snap new pieces on, take other pieces off, all without having to rebuild the entire thing. And that flexibility, that's what makes it so powerful, so scalable, and honestly, so much cheaper.
And the secret, the absolute key to this new world of data is one simple but incredibly profound idea: decoupling. We're talking about separating the core jobs, storing the data and processing the data. By pulling them apart, we can scale them totally independently. And that, right there, is the secret sauce that unlocks the ability to handle 1 trillion rows of data.
Think about it like this. Your storage is a massive library, and your compute is the team of librarians who find the books. In the old, coupled model, the library and the librarians were one and the same. To get more books, you literally had to build a whole new library with a whole new staff. It was crazy. In this new, decoupled world, the library and the librarians are separate. You can add as many books as you want to your library, infinitely really, without having to hire a single extra librarian until you need one. That's the breakthrough. So this whole new architecture really rests on 2 main pillars. First up, you've got storage. This is basically a giant, infinitely expandable hard drive in the cloud, something like Amazon S3. It's where all your data lives, safely and super affordably. And the second pillar? That's your compute. This is like having a supercomputer that you can rent by the second. When you need to run a query, you just spin up what's called a virtual warehouse to do the heavy lifting. And the second you're done, you spin it down. The best part? You only pay for what you actually use. Okay, so what really happens when you hit run on a query? How do all these different pieces actually talk to each other and get the job done? Let's trace the path of your SQL as it flows through the system. The very first stop for any request is the API layer. You can think of this as the bouncer at the front door of a very exclusive club. It's going to check your ID, make sure you're on the list, and validate your request before it even thinks about letting you go any further. And this API layer is kind of like a restaurant menu. You're not just yelling your order into the kitchen, right? You're making very specific requests. You can submit a new query with a post command, you can check on its status with a get command, or you can even provision a whole new compute cluster on the fly. It's all done through a really simple, clear set of instructions. So, once you're past the bouncer, your request heads to the control plane. Now, this is the brains of the whole operation. It's the air traffic controller for the entire data warehouse. It's not doing the number crunching itself, but it's making all the critical decisions, figuring out where your query needs to go and the absolute best way to process it. The control plane is basically juggling 3 main jobs. First, you have the metadata service. That's the master librarian. It has the card catalog and knows exactly where every single piece of data is located. Next up is the query engine. This is like an expert architect. It takes your request and draws up the most efficient possible blueprints for how to get the answer. And finally, there's the warehouse manager. That's the foreman on the construction site. It takes those blueprints and assigns the job to a team of workers.
Okay, the plans have been drawn up. The foreman has assigned the job, and now it's time for the real work to begin. The query gets handed off to the data plane. And this is where the magic really happens.
See, the data plane is made up of a huge fleet of these things called virtual warehouse nodes. Now, the most important word here is stateless. Think of these nodes like a team of temporary workers you hire for one specific job. They don't have permanent offices or desks. They just show up at the blueprints, grab the raw materials they need directly from the library, that storage layer, do their work of scanning and filtering, and then they're gone. And because they don't hold on to any data themselves, you can hire one of them or 1,000 of them instantly. And that is what makes the system so unbelievably flexible and scalable.
And of course, the whole thing sits on top of that fundamental foundation, the storage layer. This is the bedrock of the entire data warehouse. It's where all the data lives forever, and it's what makes everything else we've talked about even possible.
And the data down here is stored in a really special format that's just optimized for pure speed. It's organized in columns, not rows. Imagine a library where all the books on a single subject are perfectly grouped together so you can find what you need in a flash. The files are also what we call immutable, meaning they're write once, which is great for data integrity. And of course, because it's on cloud storage like S3, it is, for all intents and purposes, limitless.
So what's the bottom line? What's the big payoff? Why is this new architecture so much better than the old way of doing things? Well, it really all comes down to three things: elasticity, speed, and maybe most importantly, cost.
So let's just nail down this term, a virtual warehouse. It's like having your own private supercomputer that you can turn on and off with the flip of a switch. You use it to run your queries, you can make it bigger or smaller on the fly if you need more power, and when you're done, you just turn it off, and you stop paying for it, instantly. And these virtual warehouses give you some serious superpowers. First, you get total isolation. That means the data science team's massive, long-running job won't slow down the finance team's urgent quarterly report. No more noisy neighbors. Second, auto-scaling. The system just automatically adds or removes workers to perfectly match your workload. And third, and this is huge, auto-suspend. The second a warehouse is idle, it shuts down, and the billing clock stops ticking. It's a completely different economic model.
And this chart right here, this shows you the staggering difference. Just look at that bar on the left. That's the old way, a fixed-size cluster that you are paying for 100% of the time, 24/7, whether you're using it or not. Now, look at the bar on the right. With this new elastic way, you're only paying for the little slivers of time you're actually using compute. That massive gap you see between them, that is just money going straight back into your business. Just how much can you save? We're talking up to 70%. 70! Just by not paying for processors to sit around doing nothing. For any organization, that's not just a small improvement, it's a fundamental shift in the entire economics of data. All right, let's bring it all home. We've gone on a pretty deep journey through this modern data blueprint. So what are the key takeaways you really need to remember? This entire philosophy, this whole system, really boils down to just a few core ideas. The absolute foundation is the separation of storage and compute. On top of that, you have a smart control plane managing everything, and a powerful, stateless data plane doing all the work. And this whole setup allows for total workload isolation using those virtual warehouses. It's a pretty simple set of rules that gives you incredible power and flexibility.
So if you're in an interview and someone asks you to describe this, here's your one-sentence killer summary. It's a system where you store all your data in one cheap, limitless place, and then you summon precisely the right amount of processing power only for the moments you need it to get your answers. It's really that elegant in concept.
And that really leaves us with a final pretty exciting thought. When the old barriers of scale and cost are effectively gone, when data is essentially limitless and compute is totally on demand, well, the possibilities become endless. The real question isn't what can be done, but what problems will we solve next? What will you build with it?